Hey guys, Dave Ashenbrenner here, and today I've got a special treat for you. We're going to do some shop time and get ready. We are just unboxed a TronXY or TronXY, however they pronounce it, S3X, supposedly a CR10 clone, but we're going to see how close they come to that description in just a minute here. I'm going to go through this thing. This is not a paid advertisement. I'm not going to go through and complain about a bunch of stuff. I'm just going to tell you what it is. So we're going to put this up against the CR10 if anybody's wondering what the differences are, and we're going to explain it to you in a mechanical way. So I'm going mechanical on you today, so get ready. Thank you. Okay, the first part of our review will be just observing what we see. I took the top off. We want this to be kind of what you're getting when you get this kit. It is cheaper. First thing that really struck me was all the wiring on this actually seems a little more robust than the CR10. However, at close inspection, these are spade terminals like they would use on motorcycles or motor scooters or automobiles. These all hook together with the little, I guess they call them spade terminals. That's that flat terminal, and it receives it. Nothing wrong with that. It's they're actually made to take very high amperage, but it's a technology thing. So they're made more like an automobile or a recreational vehicle in that sense, and not like an electronics part. So that's my first observation when I opened the box. So I thought I'd dig a little deeper when I got that far. Looking at the control box, it looks bigger than the CR10, and I was a little surprised when I opened it up. I saw the power supply, and I thought, because the box is bigger, it's making the power supply look smaller, but the power supply is actually almost an inch or 25 millimeters narrower than the CR10. I didn't take a measurement of the length of the CR10. It's quite obvious that the power supply is smaller. It looks like a well-made unit. There's no, it's got a CE sticker on it. It is a power supply, and it is a 12 volt, it is a 20 amp power supply. So nothing wrong there. If it really lives up to that 20 amps, it's fine. The other thing, and I'm going to get a little close up here with the camera, so just bear with me for a second. This is the board that they use. This seems physically about the same size as the CR10 board. There are little cooling fins, aluminum power. Oh, look at this. We've got it on all these chips. 1, 2, 3, 4. Along the bottom here, these would be for the drives. Those are little heat sinks, and they have 2 more additional ones. I can only guess that those might be for an extra extruder, maybe, and an extra Z possibly. I can get into that later. We do see all of the plugs are used up here. There's a Z, and there's a Z. So they're running a separate channel. They're running both of the Z's. Unlike the CR10, each Z gets its own channel and its own drive, which is kind of neat. I like that part of it. That's almost traditional to some of the motion control larger units, stepper drives that you'd find on larger machines out there. And you got your ribbon, nice big LCD board. We'll take a look at the other side of that in just a minute. Good connectors here. These look like good connectors. I haven't flipped the board over to look at any of the soldering, but all of the small chips and components on here. Let me see if I can get you in a little closer. All the little chips and components here, if you look at them, they're all pretty straight. Sometimes you'll see a shoddy board where they got crooked. The components are real crooked on them. So we're going to pull out here. These plugs seem really robust. Everything looks pretty straight here. I'm not a big fan. This has the small micro. This has the micro card reader in it. If you look from this end, excuse me, right there. The micro card reader, a little hard to handle those. I've got an adapter for my CR10, for all my CR10s. I just ordered a number of them now. And I like the bigger SD cards on those. They're easy to keep track of. You can write on them. color code them or whatever you want to do for the different kind of jobs. We do a lot of production work here, so it's real important for us to keep track of which card is which. So it helps us catalog them. So nice big fan on here. It's a big cooling fan, only one though. There was a cooling fan in the power supply, and this one is for the power supply and board. So we put this back together. Nice sturdy steel cover on here, although I did get, mine has got a little ding in it on top, and that was, nothing really looked like it collided with it in shipment, so they put it in the box like that. It was assembled with a dented cover. This is a little clumsy putting this together. It catches on here and then snaps down in the back. I'll fiddle with that later, but I just wanted to give you a shot of the screen. The screen looks quite a bit smaller on here. And I'm going to give you a little comparison to the CR10. I'll be right back. So I checked, and the screen size is exactly the same on this and the CR10. I think the bigger box makes it look a little bit smaller. So it's got a nice button here. This really got some neat detents in it. Operates really well. I don't know if it's just the button itself that makes it feel more robust or makes it feel better, but it's got a real smooth movement to it. I would imagine a lot of these use the same controls, so that might be a perception on that. These are the screws that we put together with non-sheet metal screws. These are threaded screws, pretty nice there. Once again, we're going to look this over. We've got the automotive type fittings, automotive type wiring. They give you a nice manual. It's been stapled together. This is a little bit, I mean, some information, bad information, I shouldn't say bad. Sketchy information. Some information is better than no information on here. Basically on a one-sided printer, looks like they printed this. Of course, once again, nothing wrong with that. It's information they give you. They tell you the components that come with it. They tell you how to install your spool holder. Spool holder is all metal, by the way, which is a kind of a nice little feature. All the plug locations on it. E motor, X motor. And I don't see any kind of warranty or anything here. They do mention to plug it over to the 120 from the 240, 220. Mine came with it on 110. That's always nice to check that first so you don't have any problems with that. And a plastic build sheet. This is, I mean, like Lexan, maybe Lexan plastic, or maybe it's lucite plastic. And this is your build surface. I'm sorry, this isn't your build surface. This is your hot plate right here. And directly underneath this is attached the heater. Looks like a real nice flat sheet here. We'll do a quick little test on this. So just throw this on here, and yeah, it looks relatively flat relative to the surface of that. It does bow down in the middle. It does bow down in the middle a little bit. I'm going to say maybe a millimeter, maybe just a little more in the center. Not a deal breaker. Not a deal breaker at all. And then they have this, you're probably familiar with this type of build sheet where it's got the sticky on the back. And I'm not a real big fan of this. Anytime you use plastic, you're going to have a insulation factor to it. It's got a kind of an R factor that takes a little heat away from your sheet. A lot of guys like them. I have no problem with it. If I was going with plastic, I think I'd pick something flexible. Maybe that's the idea of what this is. You glue this sheet to this sheet. Now you got something flexible where you can pop your stuff off. That's great. The scraper thing, after I got gouged the first time, damn near got an ambulance ride from it. I was not a fan of the glass. Glass is pretty bad stuff. They've kind of been going away from that, and I'm glad. Glass is very heavy, and it does the moment load thing when it shifts back and forth, so that causes a lot of problems of its own. Looking at the build, a little closer at the actual build, we're going to flip this over. I like, on my CR10, at least on the standard CR10, they have a rail like the sides here. I think they have one of those running down the middle, and all of these wheels clamp to it, and it depends on that to be straight. I like the fact that they put these away from each other so you have that much more stability to it. That way the plate can't get the leverage on the machine itself. It's a good thing. It's a good thing. However, I'm not real sure. This is metal, so that's nice. Okay, and they got the metal plate. I thought at first it's got a little grain to it, like the hair cell plastic that you see, the hair cell styrene plastic, but it looks pretty good. S3X, a little classy. It's carved right in. Looks like it's laser cut in there. All these parts look laser cut. Not a real big fan of these zip ties. They went with just regular screws and zip tied this belt. This looks like a 6mm belt, and it doesn't look like this one I can just tell by the way it flexes that it doesn't have the aramid fibers or the nylon fibers in it. Looks a little bit flimsy there. I can't tell you that for a fact, and that leads to a little bit of the error correction when you're doing a print, that little bit of vibration to the print there. So looking at all of these are the nice thick ones. This has got the nice thick extrusions. They're not hollowed out on the ends like some are. I will say this, they aren't flush to the ends, so I think that's a build quality thing when they put this together. I don't know that it matters that much on this. I like the big feet. They got really huge feet on the bottom of them, real stable, and it's open and they're a little cushy on the bottom, which is okay. No caps. The CR10, they pay attention to the finishing touches on the CR10, and there are no caps on this. Once again, probably doesn't affect performance. Who cares? These get a little sharp. I don't know if you are a fan of the getting cut when you're handling a machine, but I'm not. All of the fasteners, other than a couple of them on here, are either slotted or Phillips head, or a combination of both slotted and Phillips head. Not a big fan of that either. I kind of like the Allen head screws. The Allen head screws are chances are you have a stainless steel fastener with the Allen head screws. When you get a Phillips screw, that's a mild steel screw, probably grade number 2, no more than grade number 4 on those. So know that the screws are not as high a grade on these as what they are, and they're not stainless steel. I could do a test with a magnet here. I'll probably do that shortly. The other thing is the bed leveling here. They got really flimsy, weak springs. It's just not fair when you're trying to do something like this, and you're reaching around to try to level the bed, and you have to screw around with these to get the tension right on them. Not a big deal for me. First thing I'm going to do with this is put a stinger on it where it's automatically going to go down and touch the bed and eliminate all that fooling around, but to a lot of people that matters. I also noticed they countersunk some of the other screws around the edges, and I'm not real sure why. Maybe that's an afterthought. Maybe these fit other beds. Maybe it's so you can turn it the other direction if you want. I'm not real sure about that, but looking at, well, that explains why that got dinged. Anyway, these are these little belt tensioners here. It's a clever idea. They got the little wing nuts on here. Once again, I'm really not sure of the quality of the steel here, but they're real difficult. The corners really dig into your fingers if you want to get any tension on them. I guess that would keep them from getting over tensioned. Also not sure about these wheels. If these are ball bearings inside here, that would be worth a check, because with this going back and forth all the time, knowing that this is a ball bearing in here would be really nice. Pressed fiberboard. This is pressed fiberboard. These pieces in here, definitely they lost it there. They lost me on that one. It looks like there's a metal plate in between, sandwiched in between them to give them a little strength. It's just sheet metal, just a small sheet metal plate, which they could have done that with plastic. I'm not sure what they were thinking there, but it wasn't good thoughts. Wasn't good thoughts. So let's just real quick take a look at the other end of this. We're going to see where the motor's mounted, and here's kind of an interesting thing here. Let me set this down for a moment. I'm going to get some model numbers and measurements on that motor. Okay, let's take a look at the motors here. See what kind of motors they use. This is a CR10 motor, and this is what they use for the Z's. It's a shorter frame motor. It's a 130 and change, 136 or something like that. The CR10 uses a 156 frame on their Y. I just went over and measured it. So we're just going to take a look at this. 156, very similar to the CR10. We're just going to compare the size of the motor. This I like that frame size. Okay, frame size. It's a NEMA 17, which is a standard for those. So that's all good there. They use a 6 pin on their drive on their motors. So it's a 6-wire motor. So everything's looking good. I like the cable covering here. They use a lot of zip ties. Once again, the end switches on here look more like an industrial style end switch than an electronic end switch. I actually use these. Let's get you a little closer to that. I actually use something like this on my plasma cutter. It's a little bigger, industry standard. So it's a robust. I don't know what it looks like inside, but the outside it looks great. I've had real good luck with the CR10 end switches. They're very accurate. They come in every time just about in the same spot. So not sure about this. I couldn't say unless I actually run a test on it. So one other thing that stood out at me is these T braces on here. The CR10 has a lot wider and a lot taller brace on here, and I can get you the numbers on that too, but just something that stands out at me here. And the rest of this, it was relatively similar. I would ditch the belt, just not knowing what this is, not waiting for a problem to occur. I think I'd ditch that belt, and I would for sure ditch this design over here. The cardboard, pressed cardboard, it's going to work. How long is it going to last? I don't know. I don't think my fingers can take this. I might print a knob for the end of this, for this little wing nut here. I don't like any of these wing nuts. This is really not the way to go. Probably replace all these bolts with, I have bolts I stock with knobs on the bottom of them. But before long, I'm just going to put spacers in them and lock them into place anyway. So that's probably a moot point. But for the rest of you guys that plan on actually using them, that's a good point. So we're going to get this out of the way. Let me bring I'll tell you what I'll do. Let me bring this into focus here. Okay, similar to the CR10, you've got your dual Z. This is way off to one side. I can only guess. Oh, it looks like it's been fastened into place? No, it just looks like it's adjusted off. You've got the little cardboard end switch over here. I don't know if you can see this. This is looks like it was cut with a router or something here, this cardboard. Here's your little connectors. This is once again your automotive or your RV style connectors on here. This is one of those end switches, same kind. Can't say anything bad about that as of yet. Here is your extruder. Ancient Chinese secret. This is not a good looking one. However, in the way of guiding the extrusion, they've got a neat little, I don't know if you can see, a little boss that sticks out here where the extrusion comes through. Let's see what's inside there. Okay. It was in about that far. So I suspect it's bottoming out inside of this fitting. It's not a through style where you cut this and it would guide the filament in. I'm a big fan of that. You know, this is pretty robust here. This looks like it's even metal. I would give this a chance right here. I like their design of this. The CR10 kind of falls down because it's plastic. This looks a little bit more robust, like it's the M8 type, and it looks like they put a little bit of consciousness into the design there. Little problem here. This motor looks like it was bent in shipment. That's just a loose screw over here. They use these little, I'm a fan of this type of coupling here, this type of motor coupling. If you see, CR10s are now shipping them with the red, it's called a Lovejoy connector, and it's made for high speed, low vibration. Somebody wasn't paying attention when they put that on the new CR10, so this has got the larger motors than the CR10 has. This is actually a larger, this is a CR10 Z motor, and this goes a little bit bigger. That looks like about another 10 millimeters longer on those. So similar to what the the Y motor is. And we're going to look at the X motor. The extruder sports the same thing, and so does the X. And yeah, these look real nice. This is, at first glance, it looked like it could be an anti-backlash, but it's not. And this looks like the standard the 4-start, which means there's 4 threads that run down the screw on here. So that's all pretty standard. I'm going to give this thing a, just barely passing grade for some of the stuff on here. Here's another little heads up. These bearing holders here, they are, it looks like a flanged ball bearing on the top, and it's pressed into this plastic piece that looks like it was cut out on a router. Boy, it almost looks like it's that. Let me peel away. It might be. Yeah, it looks like that's painted cardboard. I think they try to disguise that cardboard. These look like the cardboard parts, but they could be plastic either way. The Phillips screws over here. The extruder. Let's look at the extruder and see, the hot end here on this. We're going to look this over and see what we have in store. The cover screw. This fastens on similar to the CR10. One screw here for the washer. The other one is under the fan, so we have to remove the fan to make that work. Let's try that. Well, I thought they surprised me. I thought I was going to find a cap screw on this guy, but that's a Phillips. Not very good wire routing there. I'll definitely damage that wire if I try to get that screw out. Here we go. Okay, off comes that little, looks like a 4010, your standard 4010 fan that's on the CR10. Sure enough, 12 volt, 4010, and this is a little spacer. It's apparently part of the, let's call it a fang or air diverter. And interesting part about that is there is a blank here with a little ramp, and it funnels everything down into a little hole about a ½ inch wide. There's nothing wrong with that. The fans don't have to have rounded corners on them. These centrifugal fans, by the way, I told you I was going to go mechanical on you. I grew up with HVAC family, and I went on to actually start a career in my young life, kind of following in my dad's footsteps with the HVAC. And this is a centrifugal fan. These are much better than the propeller fans like you would find that cool this off. And they do two different things. When this fan encounters any kind of a blockage on the back or the front side of it, it cavitates. It'll actually cavitate if you block the outgoing side of it. The fan, there's nowhere for the air to go, so it just starts mixing it up. A fan like this, if you block the outside of it, won't cavitate. It just builds up more pressure in here. But if you block the air coming into it, it cavitates. So they do two different things. In this case, the centrifugal fan blows air off of here, and it blows it into a smaller chamber. It will increase the velocity as you funnel down the Venturi effect of the outlet. So you'll actually get a real high flow of air coming out if you channel that down. It does not affect the amount of air coming out of this fan. It's a really great thing about these fans. So somebody did a really great thing on YouTube with that. I'll try to figure out who that is. It wasn't Tom. He usually does some good stuff, but and it wasn't these printer nerd guys either. It was somebody that is savvy with the technical stuff. And this looks like it kind of an unbreakable rubber, like a real hard rubber piece right here, and it captures the screws in it. So yeah, it's a little bit flexible here. That's kind of neat. Can't break that. Okay, pop this bad boy off. I'm not a real big guy on the Phillips screws. Not real big on Phillips. This one was, look at this one, was the screw was bent and it was cross-threaded. It was really hard to take it out. So magnetic screws, that means they're steel, not stainless. All right, looks like kind of looks like a CR10 extruder, little Chinese extruder. I'm gonna grab a CR10 one. We're gonna do some measurements here. Okay, here's one I took out of my CR10 when I converted it to the E3D. I'll just put that right next to it, and by golly, if that isn't a spitting image of that, the whole thing right down to the nozzle. This one looks like it's got a larger, maybe a 10 millimeter. This looks like about 8 millimeter flat to flat on the nozzle itself. So also, this is interesting. This is interesting. They both have the small thermistor that goes in the hole held in by the screw. Not a big fan of that. They work great. They've been working. Everything's fine. I only had trouble once with one of those. And the block looks like the same size. But one thing that kind of stood out at me, 79 and 79. Oh, let's call it 8 on these. 8 by 8. Same thing. Okay. This has Kapton tape around the outside of it, but absolutely no insulation. The CR10 unit has the cotton, the high temperature cotton insulation, with the Kapton tape around that for some insulation on it. Big fan of that. One of the problems there, and they may not encounter a problem with the stock Hotend because of the way the air flows straight across it like this. But if you get fangs, or you get two fangs against each other that are blowing, the air, when it hits each other, when the two streams hit each other, they cause a big turbulence and an airflow in this area, and you'll cool this off actually to the point where your marlin will turn your Hotend, you'll turn your machine off. I've had that happen. There's some fan designs out there where guys got the dual fang fans with the 50-20 fans and the, you know, the real elaborate setup, but I've only found that they screw your prints up. Maybe they know something I don't, but just from my standpoint. So, you know, I'm expecting the same type of performance from this as you do, with the exception of the insulation. I think we're okay with that, just the way they've got the fans designed. Motors are bigger down here. We'll have to wait and see. I'm not going to say until we actually put this thing into we'll put this thing into production, and we'll see how it goes. So thanks for being here with me. I will be back on the second installment on this. I know everybody's going to want to know how this performs. I've got a CR10 that we're going to be basically putting this up against. The CR10 basically being in that box right there. We're ready to put this up on the bench. Now, I'll say one thing, I'm not qualifying myself as some kind of expert or someone who's trying to sell these. I don't get Patreon, I don't get kickbacks from DearBest or anyone on this. This is just my own opinion. Mechanically, looking at these mechanically, this is some information that you very seldom get when you're looking at these machines. A lot of people will tell you, you know, it's got this, it's got that, but there's some shortcomings that this machine has. I'm not real happy with. This is the tool kit. You do get Allen wrenches. However, I haven't found where you could use these yet. Every screw I've encountered so far on here is a Phillips head, and they do give you a Phillips head for that. They also give you a real small straight blade. This is a flat straight blade. What you would use this for, I don't know either. I know you can adjust. That's about the size you would use to adjust drives with, but I would not attempt to do it with a metal screwdriver. They give you clips. That way, they're unisex clips. There's pink and blue, depending on whether you're a boy or girl. They figure that they got it covered here with the two colors. I'm assuming that these screws are the mounting screws for the bottom, and they are the screws for the sides come into the brackets. They've got the little hammer nuts like the CR does. So no surprise there. And here's your little USB and your little micro card in here. So you got the USB, the micro card, and I do see it. Here's your interface, your USB interface into your control. So you can run this off your Cura or Simplified 3D or do whatever you need to do, upgrade to Marlin. I wanted to sneak this shot in while I was assembling this, so this is going to be a little out of sync, maybe a little out of focus, a little out of light. But when I was putting this together, I couldn't get the screw tight to screw the Z motor down, fasten it to the upright. And what I found was that when they assembled it, they didn't put a washer. They didn't put a washer under the screw, and the screw bottomed out against the other side of the extrusion before it made contact with the flange and tightened up. I thought that was noteworthy to mention that. That was a big slip up on the part of the people assembling this. You know, once again, it's probably not a deal breaker, but if you're trying to fix this, I happen to have some 4mm washers in our little library of hardware in the back. But if you don't have one of those, that's a really frustrating, real frustrating thing. The other thing is these motor brackets are tin, and you can see they flex a lot. I'm worried about backlash from this. However, there's probably never going to be enough stress on here. But another noteworthy thing is I'll end up taking this off and bending the bracket straight because it's pitched on an angle here. And also worth mentioning, as I was putting this together, I thought I would just mention this because this will get bypassed in the next video. These screws holding the brass nut down to this bracket are not in all the way. There's actually a space underneath here. My first impression of that was maybe we've got one of these anti-backlash nuts with a spring in between, but it's just shoddy. Whoever put this together, I'm going to call it. So we have an issue with this, and we're going to fix it right now. It's not the end of the world, but it's certainly noteworthy to mention these little things as you're putting it together. The average guy is not going to have the wherewithal unless he's looking for things like this. This is kind of some mechanical experience will show this, and I'm not playing down anyone's talents here, but these are the things to watch for. Let's put it that way. Also, these screws are to line up with the tops of these brackets, and they're both lined up. However, and the motor's the same here. However, it looks like somebody screwed this down in the wrong spot, and then to bring it up to the top of this lazy, instead of loosening these two grub screws here, they just pulled on the rod to get it to come up to the top, and they stretched this they stretch this coupling out. Deal breaker? No, but you know, there's evidence that whoever put these together, or their assembly line's real shoddy. So it's keep your eye out for what's going on with these things, guys. So okay, that about wraps it up, guys. I'll put this together, and we're gonna do a little test, see how this works compared to the CR10. I don't foresee any problems with it. However, I'm not real impressed mechanically. Looking at this, it's I think it falls short of the CR10, but all it has to do is work, and it brings it down into a price point where some guys can afford it if they were on the fence with the CR10. So once again, we're gonna go mechanical on you next time you come here. We're gonna look at the performance of this thing, and we're gonna put it up against the CR10. Hey, thanks for coming here, guys. I appreciate you spending your time. And I'm Dave Aschenbrenner. Don't forget to like and subscribe. Thank you.